First of all, I wasn't the only author of React. There's a huge team way smarter than me behind it. So if you guys are watching, sorry. So yeah, my name's Pete. I work on mostly the Instagram website these days. We have a pretty small team, and it's all React. And when we acquired Instagram about 1.5 years ago, we decided to try out this crazy new technology that Facebook had. And then one thing led to another, and now I started contributing to the React core. But this is not a tutorial about React. We're going to talk about functional DOM programming and kind of the benefits that can bring you. And React is going to be the vehicle for expressing that. And I'm also, along the way, going to demo an integration with Meteor, because that's what you guys are all here for. So everyone here has built a user interface, right? I'm seeing some heads nodding. OK. Everyone have a lot of fun building it? Yeah. I'm sure you never had bugs or regressions or undefined behavior, or you push it to production. It just works perfectly out of the box, right? So this is like one of the fundamental problems with UI development, right? When I'm working on a back-end service, so for example, I used to work on the back-end for Instagram and Facebook video. We wrote a unit test that said, like, when I drop this file into the encode step, at the end, I run ffprobe on it, and it says the video is good. And I have a test, and that test covered a lot of cases. But you can't really test for whether it feels right or not, because it's really hard to manage all the state that users see. So when you build an application, you don't know how big the browser window is going to be. You don't know what platform they're going to be on. You don't know if they did some series of actions that you didn't plan on them actually doing. And we decided, or when we were building applications, we discovered that state changing over time is really the fundamental evil of building UIs. So you can't test every possible path that a user can go through in your application. And so if they go through a path that you don't expect, your state can change over time, and you can find yourself in a state that you didn't plan for, and then your app just doesn't feel right. This is a problem of managing complexity. Mutable state is a very, very complex thing to reason about. And like I said, you can write tests for it, and tests are great. Tests will cover a portion of the bugs that you will find writing UIs. But they can't really check the full user experience. You can also do some static analysis as well. So if anyone here has used JS Hint, for example, or TypeScript is another static analysis tool to help you verify the integrity of your code, it's just not quite the mature solution, at least for developing UIs, for it to be particularly helpful to us. So my approach to building UIs is I don't actually try to be correct at all. I have an alternative, because I feel like trying to be correct out of the box, or right out of the gate, building a UI is really hard and is almost a futile effort. Instead, I just try to build something that's predictable. So I want my app to have the same bug every single time I run it. And I want to be able to click on the same series of buttons and have it respond the same when I'm doing it and when a user does it, whether I'm in whatever platform I'm in. Try to be predictable. It's important. So we've discovered 2 silver bullets from the functional programming world that help us. And they're not really hardcore functional programming concepts. They're just very basic principles that you can apply to an existing imperative application, or even the jQuery spaghetti app that everyone maintains. You can start applying these principles and gradually refactor your way out of this mess. The first one is composition. It's actually not really a functional programming concept, because it's just a way of combining simple functions, or it's the concept of combining simple functions to create more complicated ones. And this is another example of managing complexity. If you have to think about the entire application in your head, you're not going to be able to figure out why it's behaving the way that it's behaving. And part of that in your toolbox is building strict interfaces. And when you don't have to put all of your application in your head, it's just easier to figure out and predict what's going to happen. So you put the inputs to this subcomponent of your application, and all you need to do is think about, OK, what's that going to do? What's the output going to be? How's it going to affect the greater application? You don't have to think about every other piece. The other tool in our toolbox is idempotence. And this is basically saying, when you take some data, you put it into your process, you get the same data out every time. This is the Wikipedia definition. But the important thing is that it's very easy to predict output for a given input. Because it's idempotent, you just run it with the same set of inputs, you'll always get the same set of outputs. Now the key here is immutability. It's a really easy way to get idempotence for free. What I mean by this is, think about the class of bugs that are easy to track down and that are hard to track down. The easy bugs are when you have a repeatable behavior, and you go and you trace through the debugger, or you drop console.logs, which is my preferred way of debugging, until you find an assumption that you thought would be true and wasn't true. Then you just trace up the call stack, and you figure out what parameter coming in was incorrect, and you fix that. The problem is, if that parameter coming in to your code is mutable and is in the wrong state, you now have to track down every single site where something could have possibly mutated that parameter and figure out what the hell is going on. It's actually a really hard problem to solve. So hard, in fact, that I think it's insane to build an application with it. And when I sit down to work on an application that has shared mutable state everywhere, I go crazy. So what we should do is try to make as much of our application state immutable as possible. And we should minimize the amount of mutable state in our applications. So every application is going to need some mutable state. You're going to have to add an item to the to-do list somewhere if you're building that application. But it doesn't mean that you should put mutable state everywhere. So in our to-do list application, the quintessential example, rather than saying, OK, I'm going to append to this array with the new to-do item, and I'm going to update the completed count, the incompleted count, and the total count on the to-do list, just add it to the end of the array and recompute every time you need that data off of the length of that array. You can think of this as like a fully normalized data model in your application. So if anyone here has worked with like a traditional SQL database, I don't know if this is the right crowd for people that have worked with traditional SQL databases. But you know that one of the things they tell you to do initially when you're learning is try to normalize the data as much as possible, so you have no repeated data in your application. The reason they suggest that you do that is because it's a lot easier to keep everything consistent and to reason about what your application is going to do. You start to move away from that and start denormalizing when you need that performance. When you want to shard to multiple databases, you start having redundant data everywhere. So by using extra mutable state, it's almost like a form of premature optimization. So instead, you should just be lazy and compute off of the fundamental source of truth in your application. And that source of truth should have one clear owner. So if you have a piece of mutable data, so let's say the to-do list again, all of the code that mutates that should live in one place. And it should be the gateway to this mutable state. So you can reason about exactly what's going to happen and how things are going to interact. And if you've ever worked with concurrency or watched someone work with concurrency and watched them kind of descend into madness, they'll talk about how bad concurrency is. It's actually not concurrency that is the real kind of mind bender. It's the fact that you have shared mutable state. And concurrency just amplifies the problem and makes it harder to reason about than a single-threaded program. But it's shared mutable state and not having a clear ownership of that data that makes it really hard to understand. Meteor gets this. Meteor is the single source of truth of the data in many of your applications, at least on the model level. And it's a reactive system. Whenever the data changes, rather than you caching that data all over your application, Meteor's auto-dep system basically just reruns your code, you recompute everything, and you're happy. React, which is the JavaScript library that I contribute to, also gets it. So I'm going to give you a high-level overview. And then I'll race through some code samples because I'm talking very slowly, I hope. We call it a library for creating user interfaces, but that's not very descriptive. We're not templating. We're not MVC. You can think of us like a declarative jQuery. So everyone out there who talks about React versus Angular and React versus Ember and React versus Meteor, it's not that. It's just a better way to manipulate the DOM and handle events. And the way that you do it, rather than imperatively touching the DOM, you write idempotent composable functions, which is a core tenet of maintainable software. And you have data come into your function, and you emit these virtual DOM representations as return values. And when the data changes, you just run that function again with the new data, and you re-render. And what React does is React diffs the previous result of that render with the new render, or the new virtual DOM, and does the minimal set of DOM operations required to apply those changes to the DOM. So you can think of it like rendering and re-rendering a virtual DOM, but it's actually a little more than that. And I'm not going to get too much into the sales pitch, but it's a view hierarchy. It's a language of higher level components and the abstractions that make sense for your application. And it's rendering to any sort of backend you want. So it's actually a DOM agnostic library. So right now we have backends for rendering to a browser DOM, rendering to a canvas, and rendering to a string. So you can actually run React on the server, render to an HTML string, not bother booting up an expensive DOM or using Phantom.js or something. And I'll show a demo of that in this talk. So let's use Meteor and React together. They seem like they're a pretty good fit for each other. So I'm going to build a basic tic-tac-toe game with Meteor, and I'm going to show you the code that I came up with. Now, I'm not the best Meteor programmer, so if I did something stupid, I'm sorry. So here is the first pass I took at the application. All right, we're on the client, and we create this board object that I just came up with. Whoop. So I wanted to write kind of the simplest data object to represent the game that I could come up with. And I'm going to kind of wave my hands over this, but we've got a collection that has my game, and it's got 3 pieces of data on it. It's got the name of the game, which you don't really care about. It's got the moves, which maps an x and y coordinate on the game board to whether x, o, or nobody owns that tile. And then it has the current person's turn on it. And so we use our plain old Meteor API here, find one, to fetch that data. And we put some business logic on it. So we have a move method that checks if there's already somebody there, and if not, it writes it onto the game board. Bigger? How's that? All right. And we've got some other accessors. Do you buy that this is kind of just a very simple Meteor thing? All right, so we've got it in here. We can say move 0, 0, board.get 0, 0. We've got x there. And then if I try to move there again, it'll yell at me. Pretty straightforward, right? Cool. All right, so Meteor's awesome, by the way. It just like reloads your stuff for you. I don't know if you guys know about this. It's great. So I've checked out step 2, which is where I actually build a user interface on top of this with React. Now, I want to stress that this is not a tutorial about why React is awesome, the best way to build applications with React. This is about why modeling your UI as pure functions is beneficial. So this is not the best practice in the way that most people write React apps, but I would love to talk to you about it afterwards if you're interested. But here is our function that renders the UI. It's a pure function. It takes in board, the game board instance that I just showed you, and it returns these basically these React.dom objects. Now, I know you can't quite fit the whole thing in there. But what we basically do, I'll walk you right through it. We iterate over every row and every column. We go into our board and we say, hey, board, give me what the value should be at this x and y. Assign a certain CSS class to it. And then we append to this array with a div. Now I want to stress that these objects are not actual DOM nodes. They're descriptions of what we want the DOM to be. Because we can run this render method as much as we want. It's inexpensive. We diff the 2 representations. And then React takes care of all the DOM node creation and management for us. So blah, blah, blah. We push some stuff onto arrays, and we render a div. Let's look at the main app over here. Oh, actually, first of all, so this is our HTML file. All it is a script tag to React. There's nothing in there. I have another talk from JSConf where I talk about how evil templates are. I'll save you that for this talk. But here's the only change that I made to my application from before. All I did was say, hey, React, call this function with this model, render the component into the body. And then Meteor is like, yo, when the data changes, like, we'll just run this again. And React is like, great. When I get this new version of the virtual DOM, I'll diff it and make sure it's up to date. So here's the result. It's not a great game. But you can see I actually already made a change to Meteor from the command line previously. And oh, what is going on? Oh, yeah. But I can't click anything. Because all we're doing is rendering what's already in the database. So if I were to kind of do a move here, The red is X's, the blue is O's. It's easier to see on the screen. But it's brought up to date. And I didn't even think about it with React. React just did it for you. And I can actually prove to you that we aren't throwing out the DOM by saying something like this. Actually, let's. So I just did a manual change of the DOM there. And then if I move someplace else, it's still there. Even though React is managing the whole thing and you're conceptually re-rendering, it didn't mutate the DOM there. So that's pretty cool. We sold that like if we want to debug this, we just look at the inputs, and we look at the outputs, and then we trace through the flow of that function. Pretty straightforward, right? Cool. So let's look at step 3. I don't even remember what step 3 does. Actually, I do. I lied. OK. So our app is still the same. I just made some changes to the front end. Now, the key change I made is right here. I added a click handler to this, this virtual DOM component. Again, keep in mind that even though this looks like an inline handler, since it's not a real DOM node, we can use whatever implementation strategy we want to make it fast. So we actually only have a single click listener on the whole document and dispatch based on that. But all we're doing is saying, hey, when you click on this, trigger a move at this index, or this x and this y coordinate. And I added a button down here that will call that reset method that'll reset the game. But you can see, it just works. I didn't change how my Meteor code, I didn't do anything. I just added a single line of code. We're just conceptually re-rendering everything. Step 4. OK. So I might have another slide about that. Oh, yeah. So I had a slide about React and Meteor being pretty awesome. And I had a slide about being crazy. Let's swap out the back end. So if you want to test this, personally, I'm not really super familiar with Meteor's testing strategies, but I just don't want to talk to the network. And I want a different backing store for the board that doesn't talk to Meteor. So I just threw out the old board. And now there's no Meteor code here. We're just using plain old JavaScript objects. And since before Meteor was handling the changes for us, I had this on-change handler, which basically says, hey, whenever you make a move or reset the game, just call whatever callback you provide here. The rest of the logic is the same. So we call that callback down here. And I've changed this a little bit. So you notice I don't use deps anymore because I'm not talking to Meteor at all. And instead, I'm just saying, hey, create a new board. And when that board changes, re-render. It's as simple as that. Now, the key takeaway here is not the few lines of code. It's the fact that when you have a virtual DOM diffing representation, you don't have to track your changes all throughout the application. So if you've used a traditional data binding system, a lot of times you'll have to explicitly provide computed properties. Or maybe the system underneath it does some sort of tracking for it. But it usually bleeds into your application. With this, you're just passing in regular JavaScript. You're not doing anything magical. Until now. So here's a problem, right? We got this application, and it's pretty cool, and it's in Meteor, and it's live updating. And you know what I got to do? I got to reset it. All right. Come on. All right, so I got this application. Works pretty well. Here's a problem. I want to be the next big startup. And this is all of the data that Google has to index me. And I'm going to get penalized if it has to run JavaScript. What if I could instead just create a static version of that page that looks exactly the same, but just doesn't have any interaction? And I will prove to you that this is static by viewing the source. And this has some React IDs in there that we actually are getting rid of in the next release. But this is static HTML. Because we're rendering to a virtual DOM, we don't have a dependency on the browser, so we can render to an HTML string. And in fact, though I couldn't figure out how to set it up in Meteor in time for this demo, if you were to run React on this markup, it would reuse it rather than re-rendering everything. So you get the benefits of SEO and that first fast page load experience, but you can still write your code just like you normally would. And so the code for this is still exactly the same for the React components. I didn't change anything. However, I was bugging a bunch of people on IRC. They told me about this router thing. And all I did was I said, hey, create the Meteor board like I always do. Call render component to string, the same, just like I call render component, and return the response. You might notice some weirdness with the async stuff here. That's because it's fake async. But that's kind of an implementation detail. It's going to be synchronous in the next version. And last, step 6. So the last one. I talked about the benefits of immutable data, right? We can use these benefits in an existing Meteor app because Meteor just gives us regular JavaScript objects, and I don't think it mutates them. So what I can actually do is I can play the game a little bit, and then I can do an instant replay. Pretty cool. You know how much code I had to do to write that? Not very much. Every time deps.autorun gets called, I just push the board onto this array, which is the log. And then I have a button down there that calls this replay function that just says, hey, go through the array, every second re-render it with the next item in the log. And I didn't even have to think about it. So this has a lot of really cool implications. Imagine being able to save a log of all the stuff that the user has done, zip it up, and send it to the server when they crash. You can replay exactly what happened for them to get into that state, and then realize that you had too much mutable state and get rid of it and make your app better. I'm sorry, I went way over time. So yeah, that's about it. Thank you guys for having me. Any questions? Yeah?
How does React play with SVG?
How does React play with SVG? So we have an open source library called React Art that renders to a sequence of operations that we call art operations. Now we have to render graphics on Facebook for our Page Insights product. And they're kind of data visualizations of impressions and reach. You can go and see that at some point. But we need to support like old IE8. So we actually have the ability to render to this intermediate layer of art components. And those can then turn into either SVG, canvas operations, or VML, depending on which backend we want to render to based on the environment. Sweet. Yeah?
Do you have any comments on web components and how React might have to change or not if once that sort of becomes mainstream, or do you think it will?
Well, the question was about React and its relationship with web components. I think that's a very broad and nuanced question to answer. But I can speak kind of at a high level that Facebook was not super involved with standardization efforts a year and a half ago. And since then, we've joined TC39. We're doing a lot more outreach to try to get a seat at the table and talk about how we could benefit each other with web components. What I will say is that web components is mostly focused on DOM, so new DOM APIs to make working with the DOM easier. We actually really don't like the DOM, and we put the DOM in its own little corner. So we're looking forward to taking advantage of Shadow DOM and being able to style native components. But we think that our approach to composition and flowing data between components, which I didn't really talk too much about, is superior to kind of traditional data binding approaches where you observe changes and trigger kind of imperatively updates. So we're hoping that we can kind of spread the gospel of immutability and lazy architectures.
I have a question from Twitter.
Cool.
What is your view on JavaScript front-end ecosystem in the next couple of years?
Well, it's an interesting time, for sure. It's great to see that there's like kind of this Cambrian explosion of environments and libraries and ways to use JavaScript. I'm really sold on NPM being the way that we're going to share components in the future, mainly because it does really fine-grained dependency tracking, and a lot of people have already agreed on it. So I'm really hoping that if we build new ways to share code in the future, we build it on top of NPM rather than go and reinvent the whole thing from scratch. I think that the fact that native applications have gained a lot of ground in the past couple of years is really important, has really serious implications for JavaScript, for the JavaScript community. And we really need to kind of take our performance and interaction standards to the next level, and if we want the people to use web apps. Does that answer the question?
I guess so.
Do you have a question?
Yeah, for what projects should we not use React? Like, what are some caveats that I'm going to be aware of, at least at this stage of the game?
Sure. The question was what is React bad at, and what are its caveats, and when shouldn't you use it for a project? So React uses composition and is very opinionated about composition. That naturally lends itself to hierarchies. So if your data model looks like a hierarchy, then React is a really good fit for it. However, if it really doesn't look like a hierarchy, then React probably isn't a great fit for your application. So if you're thinking about like a particle simulation or something, for example, where you've got a lot of flat kind of objects existing in space and they're all kind of colliding with each other and they could collide with anybody, or a game, certain types of games, React might not be great for that. Also, if you don't want to write JavaScript, React is probably not a good thing. Yeah?
It is definitely to use Meteor for your data and React for rendering. Let's say I didn't want to use Meteor. What are the best practices for using React?
Let's say you don't want to use Meteor. What are the best practices for using React? Was the question from a Meteor team member. So, we're still figuring those out. So the community and Instagram and Facebook all build applications in different ways because this is less of a full stack framework and much more of a declarative jQuery lower level type of thing. So the way that Facebook builds applications is we have a centralized queue of immutable messages, and we drop in those messages. And we say, an example of that type of message would be, user wants to like this photo. And then we have systems that listen on that. One of them is the photo service, you can think of it as. We call it a store. It picks up on that, and it tweaks the like button state in the UI by informing React, hey, this data had changed. We have another store which picks up on that message and sends the request to the server. Server comes back, and rather than directly updating that data itself, it drops into that queue again. So the store that actually renders the UI can say, oh, I went from a user saying he liked the photo to the server saying he disliked the photo. So this is probably an error condition, so show a little exclamation mark next to the like button for a server error or something like that. With Instagram, we just have two ways of fetching pages. We have the HTML way of fetching pages, and we have the JSON way of fetching pages. And when we do a page request and our client-side router kicks in, we just fetch the JSON version and then re-render our components with that data. So it really depends on your use case and that kind of thing. I know that the Clojure community is doing a lot of interesting stuff with how they manage data with core async. Sure.
What does it mean to render to the canvas? Can you do the whole DOM in the canvas, like an iframe on this?
The question was, what does it mean to render to the canvas? So we don't have like a HTML implementation for the canvas. What this means is that React is just a way to map a view hierarchy that you describe in like a functional way to any sort of backend that you want. So we have a plugin that drops in that says, hey, this is the plugin for the DOM. And it says, OK, the class name on this div changed from nothing to class A, and queue like a get or a set property or set attribute. So we've done that for the canvas as well, but it doesn't support the full dialect of HTML and CSS. It only supports this language for reactive data visualization called art. So if you want to draw like charts and bar graphs and stuff like that.
One last question.
Last question.
You had mentioned you don't see it as like a template. Like if you were to drop this in like any MVC framework, which pieces do you see it taken out? Like, is it pretty much taking out the template and the view model, or what?
The first thing that you do generally is you say, OK, right, repeat the question. Thank you. The question is, where does this drop into a traditional MVC stack? Normally, you start out by saying, OK, I don't want to take a big risk on this technology. I'm going to try it out for one template or one partial or one tiny little piece of my view where everything else is managed by the controllers and models. What you'll find is that when you're developing an MVC application, it's usually like some pretty well-factored models over here, and then really tightly coupled views and really tightly coupled controller, and both are really monolithic. So your controller basically needs to know everything about the stack of views that you have. So with React, since you're building with components that are smarter than templates, you can start to move some of that controller logic that makes sense into your components. So a good example would be you want your model data, like the actual contents of the to-do list, to live in your models and have the controller just basically proxy that over to the view. But which tab you're on, whether it's the completed tab or the active tab, that's not really model logic, really, right? Like people call that view model, and then they kind of like splurge it all together into like one big ball of mud and pass it over to the views. With React, you would say, oh, the tab switcher component owns that mutable state. So now you can test that. You can refactor your code to more elegantly express kind of the way that your application works. Does that make sense? OK.
All right. Thank you.
Thank you.